So today is Holy Tuesday. So we will not gonna be conducting a synchronous class obviously in Thursday because that's a holiday. We have a long weekend ahead from Thursday to Friday. So we will combine the two synchronous discussions, two topics today. Okay. So we'll be expecting to end at around 12 or 12:30. So yeah, for today we will finish the module 3. So we still haven't yet discussed the hydrostatic force on curved surfaces. So we will discuss that. We will answer a problem or an example regarding that topic. And also, we will discuss the basics of the analysis of dams. Okay, so that's module 4. We will finish module 3 and module 4 today. Okay, so we are already 39. If we are ready to learn, please type dams in the chat box. Okay, so I will share my screen. Can you see my screen, class? Okay, sige. So let us make this full screen. Okay, so last time we discussed hydrostatic force on flat surfaces. So we just basically solve for what? The horizontal force. Okay, so we draw the pressure diagram. Let's say we have a flat surface that is vertical. This is the flat surface. Okay. Let's have this in different color. Say this is your flat surface. Now the pressure diagram looks like or is shaped like a triangle. Okay, so this is your flat surface. This is your water. So it's mostly submerged in water. So the pressure diagram will look like a triangle or will shape like a triangle because the pressure at the bottom is greater than the pressure at the top. So we already know that because the depth as we go deeper into a fluid, into a water, the weight of the fluid above us goes up as well. So at the bottom, the pressure is greatest, and at the top, the pressure is the least because we have less fluid that we carry basically. So last last meeting, just a quick recap. We solved for this F sub h. Now this F sub h is the hydrostatic force that's acting on this flat surface. It is the magnitude. Okay? So this triangle right here, this pressure diagram, can be represented by this single F sub H. So let's say the magnitude of this F sub H is 6,000 newtons. So the pressure that's exerted by this fluid, this water, is 6,000 newtons. Now we also solve for this position of F sub H. So it's also important for us to design the proper structure for it. Okay? So if we anticipate the amount of force that will be acting on our surface, on our structure, as well as the location of that force, then we can design the proper size of the structural members that will be designing. So that's the role of civil engineers. Basically, we design structural members, we design the size of beams, of columns. In this case, we will design a structure underwater, okay? Because this is fluid mechanics. No? So going back to this, we also determine the H sub C sub E, or what is that? That is the center of pressure. So when we say center of pressure, it's the depth in which the location of the force, the magnitude of the force, or the resultant force that's acting on the flat surface. So that's the location from the surface. Okay. So basically, it's the depth. Okay, from this point to F sub H. Now, that's the case for flat surfaces. But what about curved surfaces? So, ito yung pag-uusapan natin ngayon. Okay? So, let's get right into it. Delete muna natin ito. Okay. Say we have a submerged curved surface. So, this is a submerged curved surface on a fluid that is obviously water. Okay? Now, this fluid will act on this curved surface. So it will exert pressure. The pressure, as we know, is equal to force over area. So basically, this fluid exerts force on this curved surface in all directions. Okay, you can imagine because um, the entire cross area of this curved surface is filled with water. So it will be acted upon by the force of the water, by the weight of the water. Okay? Now, if we cross multiply this area on this side, so ulit-ulit na lang natin itong ginagawa, no? So we can derive the force. So pressure times area equals force, in which pressure, the unit maybe Newton per meter squared, and then area is meter squared. So meter squared will cancel out. Newton yung magiging unit ni force. Or maybe you can have an English unit, pound per square foot. And then area is square foot. Then this will cancel out. You will be left with pounds for as the unit of the force. Okay. So that's beside the point. That's beside the point. So let's get back to the figure. So this curved surface is acted upon by the pressure due to water. Okay. What can we notice, class? The forces are slanted. Okay, they are slanted. Now, these forces, they are basically resultant forces that we can reduce to components. Okay, we can reduce it to its components. So this is a resultant, resultant. Again, we can reduce it to their x and y components. Therefore, we can compute the F sub x or the force along the horizontal and F sub y or force along vertical. So we will apply some physics, some statics into it. So, or equilibrium equations, no, sorry, into it. So we have F sub x and F sub v or F sub y, provided that we know this angle. So we can use the laws of triangle to compute f sub y and f sub x. Okay. It depends actually in the given. But yeah, we can reduce it to components, no? F sub y and f sub x. Okay, so these are the forces that are exerted by the water onto the curved surface. We have vertical and horizontal components. Now recall Newton's third law of motion. What does it say? It says Newton's third law of motion states that if we apply a force on something, on an object, on a person, anything, there will be an opposite reaction that is similar in magnitude but opposite in direction. So this curved surface will react to this force that's exerted by the water. So it will counteract these forces. So the force that will be exerted by the curved surface onto the water are this. Okay, we can see the opposing forces of these forces. Okay, so you have left force here or force to the left and force downwards. So it will be counteracted by the curved surface. This will be force to the right and then force upwards. Okay, so this is the counteracting force by the curved surface. Now, we can represent just like F sub H. Okay, just like F sub H, we have the pressure diagram. We can represent these forces, okay, these forces as a resultant, okay, as a single resultant. And we can call that F sub T or force total. Now, what is this F sub T? F sub T is the total force exerted by the fluid to the curved surface. So it accounts for the summation of the weight, that is the force downwards, and then the force in the horizontal. Okay? Because we have two components. The weight, or F sub B, is the force along the vertical, and the force along horizontal, or F sub H. So, to determine this F sub T, again, this is the resultant force of the fluid. Okay? The magnitude can be solved as square root of F sub H squared plus F sub B squared. Okay? So basically, we can reduce this kasi to a right triangle. When you see it, so you have this y component. So ito, di ba? F sub B equal to W. And then we have F sub H, and yung horizontal. And then yung hypotenuse natin is yung F sub T. Right? So this is a right triangle. We can use the Pythagorean theorem. So F sub T squared equals F sub H squared plus F sub D squared. And then you square both sides. So this will become this equation. Okay? So that's how we determine the resultant force for a curved surface. Now the question is if we can solve the resultant force using this equation or formula, how can we know, or how can we solve F sub H and F sub B in the first place? So let me show you how. We can use the equilibrium equations for us to derive the formula for F sub H and F sub B. Okay? Now for F sub H, it's similar to the F sub H for flat surface. Okay? So we have this F sub H, pressure is equal to the derivative of the force with respect to the area, dF over dA. Now cross multiplying this dA onto this side, okay, we have here the pressure diagram. Still, we will have a pressure diagram. Okay, the force, no, or dF will become FH if we integrate this one. So the integral of dF is F sub H. And this is equal to the integral of P dA. Okay, so dito siya nanggaling. Mas multiply dito, so integral of P dA. And remember, this pressure is equal to gamma H. Okay, so recall that P is equal to this. So integrating gamma H dA will become gamma H bar A, in which gamma is the unit weight of the fluid, H bar is the middle point, middle height of this fluid, okay, from the top. So we in this formula, we consider the area or the cross section to be rectangular. Okay, so please remember that. So in using this, we consider that the cross section is rectangular. So when we get h bar, it is what? If this is h bar is equal to h over 2. Okay, we get the half. Because again, the shape of this is rectangular. So we it's the same again with the f sub h of the flat surface. Okay? Same as the f sub h of a flat surface. Eh, ano ba yung h hat or h bar rather ng flat surface? That's the middle of that flat surface. That's the center. Okay, vertically of that flat surface. So h bar is equal to h over 2. And then the area is the area of this cross section. So we'll multiply the height by the width. Kung gaano kakapal yung curved surface natin. Okay? So that's f sub h. That's how we solve f sub h. Gamma h bar a. Okay, so we have here the explanation. Horizontal component of total hydrostatic force exerted by a homogeneous fluid on any surface is equal to the total force acting on its vertical projection. So just like the f sub h na of a flat surface. The location of which is on the center of pressure of the vertical projection. Okay, so that's how we compute f sub h. Now what about f sub v? So the vertical component of f sub t. So we can take the summation of forces along the vertical. Remember that gamma is equal to the weight over the volume. So cross multiplying volume, weight is equal to gamma volume, which is also equal to f sub t. Okay? So, hindi pinakita dito directly, pero yung tubig natin, may self-weight siya. Right? So, paano ba natin makuha yung weight ng tubig? So, pwede natin kunin, if given yung dimensions ng curved surface, kunin natin yung volume niya, and then multiply natin sa unit weight ni tubig. Okay? That's how we determine the weight. And then, yung F sub B, yan yung magre-resist dito. Okay? Siya yung force upwards that will resist the weight that is downwards. Okay. So that's basically it. Vertical component of the total hydrostatic force exerted by a homogeneous fluid on any surface is equal to the weight of that volume of the liquid extending vertically from the surface to the free liquid. So, kung meron pa tayo ditong tubig, we should also get the weight of that water and add that to the weight of this quarter circle shaped water to determine F sub B. Okay? So, it's the total weight. Now, F sub B is the total weight above the curved surface. Alright? So, that's F sub B. That's how we solve it. We get the weight of the water above the curved surface. So, there you have it. That's how we solve F sub B and F sub H. If we got the values, we computed the values of f sub b and f sub h, we can compute for the resultant f sub t. And that is again using this equation. So we derived this earlier. It's equal to square root of f sub h squared plus f sub b squared. And then if we want to get the angle between the f sub t and f sub h, so it's equal to this. Now where did this equation came from? Came from the triangle again. So we have this triangle, and then the angle is this. Okay, yung angle. So using the tangent function, so SOHCAHTOA, opposite over adjacent. Okay, because TOA, tangent. So tangent theta is equal to opposite side is f sub b, adjacent side is f sub h, and then getting this theta, so this will become inverse tangent of f sub b over f sub h. That's how we get the angle between the resultant force and the horizontal component. Okay, so that's how we solve hydrostatic force on curved surface. Now let's apply those concepts in solving a problem. But first, let us look at this table. So these tables, if you look at the statics books, mechanics of deformable body books, and fluid mechanics books, so any engineering mechanics books, you will find this table in the appendix part. So these formulas that we see, so we have various shapes. These are common shapes. Okay, these are common shapes. For example, this rectangle, circle, semicircle, triangle, section or segment, quarter circle, ellipse. So these are derived formulas. Derived formulas for the moment of inertia. Okay. Again, we will use moment of inertia for the computation of the eccentricity. So remember eccentricity, it's equal to I over A times H bar. So we'll use I from these tables. So say for example, the cross section is a rectangle. So we'll use BH cube over 12. If it is a circle, then we have pi r raised to 4 over 4. We do not need to memorize these formulas, but we just have to familiarize ourselves, okay, with them. So it should be given in exams. Okay. Now that's the essence of this tables. At the same time, we can see the centroid, how to get the centroid of these shapes. So for rectangle, for example, the centroid is located here. So it's half the base and half the height. For the triangle, or this is a right triangle, the centroid is located B over T from the base, or H over T, sorry. H over T from the base and B over T from this side. hopefully we master this in our statics of rigid bodies, because this was discussed in the last week, module 6 or module 5. Okay, so let's have this sample problem. Let's apply the concepts that we discussed earlier. So let us read the sample problem number 3. A 4-meter long gate curve is located in the side of a reservoir. So ito yung gate, containing water as shown in the figure. Ayan, puno siya ng tubig. Determine the magnitude of the horizontal and vertical components of the force of water on the gate. The radius of the gate is 3 meters. The depth of the water over the gate is 9 meters. Okay, so we are looking for F sub H and F sub B. Okay, so let me share my external cam. Okay, so to start, we can first draw the free body diagram for this problem. So we'll divide the figure into this section. So we have this one. We have this quarter circle. So let's draw its free body diagram. We have point A, so we can see. So this is point A. Then we have this gate that is curved. So that's right. Okay. So the question now is, what are the forces that are exerted on this gate? We have the weight, of course, of this water. So when we say weight or W, this is just the weight of this quarter circle. Okay. We also have F sub 1 here. Now, what is F sub 1? F sub 1 is the weight of the water above. Okay. The weight of the water above the quarter circle. So we have another force here. Now, what else? What are the forces? We have horizontal. Okay, so let's call this F sub 2. So these are the forces that are acting on the gate. Okay, so nothing else. Now, these forces will be counteracted by F sub H, or the force along the horizontal, and F sub B, or the force along the vertical. And these are the two variables that we need to solve. So required f sub h and f sub p. Now, since this figure is in two dimension, we can put this in the x and y coordinate system. Let's have this as the origin. So we have here the y component, imaginary, and the x component, also imaginary. Now, since we have this system of forces, we can use equilibrium equations. Again, we call equilibrium equations from static of rigid bodies. They are the summation of forces equals 0 and summation of moment equal to 0. But since we will not, there is no rotation. No? There is no rotating force. We will not use the summation of moment. So we'll just utilize the summation of forces equals 0. Okay? Now, we have two components here, x and y. So we will have summation of forces along x or along horizontal and summation of forces along y or along vertical. Okay? Now, unahin po muna natin is yung summation of forces along horizontal. Let's set this to be positive to the right. Okay. What are the forces that acts horizontally? We have F sub 2 and F sub h. We can put that into equation. Summation of forces along x equals 0. F sub 2 equals negative F sub h. Or sorry, equals positive F sub h because this will come from F sub 2 minus F sub h equals 0. Okay, because F sub 2 is going to the right, F sub h is going to the left. So this will be the equation, and then if you transpose this on the other side, so it will become this. Now this F sub h and F sub 2, recall that it's equal to gamma h bar a. That's the equation that we derived earlier. So this is gamma h bar a. Okay. Now we can draw the pressure diagram in this figure. So will look something like this. Sorry. Hanggang dito lang po yung pressure diagram natin kasi yung gate hanggang dito lang. Okay. Here's our pressure diagram. So pwede din natin yung i-drawing dito. Okay. So we have gamma h bar a. Gamma is the unit weight of the fluid. So in this case, it's water. So we have 9.81 kilonewton per meter cube. So naka-SI tayo. That's why this is the value of our unit weight. And then we multiply h bar. Now from the definition of h bar, it's the center height from the surface up to the center of the surface. Okay, so we consider this to be flat. Okay, in determining f sub h. Therefore, we have what? We can determine this depth. So ano po ito? This is 6, right? 6 meters. So 9 minus 3. And then we should get the half of 3 meters. Okay? So this is 3 over 2. This is equal to 1.5. Okay? So let me repeat that. H bar is the depth from the surface to the center of the cross area. And the cross area in this horizontal component is a rectangle. So basically, we need to get half of 3 meters, which is the height, half of 3 meters, that's 1.5, and then add this depth for us to get h bar. So basically, this is 6 plus 1.5 meters, which is equal to 7.5. So let me just write here 6 plus 1.5 meters for us to not be confused. Okay, but this is 7.5. So that's h bar. And then we multiply the area. So we have 3. Okay, we have 3 meters. That's the height. Times what? Times 4 meters. That's the length of the gate curve. Okay? So kumbaga, kung titingnan mo siya on this side, okay, and on this perspective, makikita mo, yung 4 meters, yung lapad niya. Okay, yung lapad nitong gate. So, we will multiply 3 meters by 4. Okay? So that's the area that we need. So, ano po yung f sub h? Can you help me solve the horizontal component of the force? Thanks, Cyron. 882.9 kilonewtons. Okay, so basically, we have the answer for f sub h, one of the required variable. So, next, unknown is f sub b, so force along the vertical. We can use summation of forces, equilibrium equation, along y. Okay, let's look at the free body diagram for us to come up with the equation. So we have f sub b going up, and then we have f sub 1 and w going down. So the equation will become f sub b positive minus w minus f sub 1 equals 0. Okay, coming from this free body diagram. Now again, this f sub 1 and w, these are weights. Okay, f sub 1 is the weight the water above the quarter circle, and the W is the weight of the water that is in the shape of a quarter circle. So let's compute F sub 1 and W separately. So let's start with F sub 1. So to compute for the weight, since we have the dimensions, we can use this formula, gamma times the volume. So we have unit weight of water to be 9.81 kilonewton meter cube times. So we have 6 meters by 3 meters. The dimension of this um, rectangular shape figure. So 6 meters times 3 meters, and then times the thickness or length, 4 meters. Okay, so yun yung lapad nitong rectangular shape na tubig na to. So, times 4. So, ano po yung F sub 1? Okay. So, thanks, Andrea. 70,000 some 706,000. But we can convert that to kilonewtons para mas uniform tayo. Okay, so we divide by 1,000, it becomes 706.32 kilonewtons. Okay, so thank you. That's F sub 1. What about W? So W again is the weight of the water that is in the shape of this quarter circle. We need to determine the volume of that. So unit weight of water is again 9.81 kilonewton per meter cube. And then the volume, so volume of this quarter circle is equal to what? Pi r squared is the area. Okay? Pi r squared is the area for a circle. Now, since this is a quarter circle, so we divide it by 4. Okay? So this is the area now for a quarter circle. And then we have to multiply the length by 4 meters. Therefore, this will be pi times t squared over 4 times 4. Okay? 3 is the radius and 4 is the length of the key. So 4 will cancel. This will become 9 pi. This is in cubic meters. Okay, we can substitute that to this. So what is the weight? What is the weight po in kilonewtons? Okay. Thanks, Andrea. 277.37 kilonewton. Now we can substitute these two values in this equation. So it will become F sub B minus 277.37 minus 706.32 equals 0. Therefore, F sub B is equal to what? Nine eight three point 69 kilonewtons. Okay. So we solved the problem basically. F sub H and F sub B. So these are the answers. Now what if we the problem asks for the resultant force F sub T. So compute for F sub T, that's square root of F sub H squared plus F sub B squared. So this will be 882.9 squared plus 983.69 squared. Ano po yung resultant force natin? Okay, it's equal to 1,321.8 kilonewtons. What if the problem asks for the angle? Okay, so you have here the vertical and horizontal components. Ito yung F sub T natin na may magnitude na 1,321.8 kilonewtons. So what if ang tinanong is yung angle? So can be solved by shift tangent or inverse tangent F sub B over F sub H. Is equal to 48. So this is 48. Okay, let us check if our answers are correct. So F sub H 882, then F sub B 980. Now, what if the question asks for the location of F sub H, location of F sub H and F sub B? Okay, so paano natin isosolve ito? Tsaka ito. Let's have another paper. Okay, so let's start with f sub h first. So f sub h, the location, can be computed by solving the center of pressure, okay? The depth of the center of pressure. So recall h sub Cp can be computed by h bar plus the eccentricity. Okay? So h bar natin, we already have that. It's 7.5 meters. We just have to compute the eccentricity. Now eccentricity formula is moment of inertia over area times h bar. Now we have a rectangular figure, therefore we will use, let's go to this, we will use this bh cube over 12 then over a times h bar. So this will become 4 meters, that's the base, times height, so height is 3 cube over 12 over the area, so it's rectangular, therefore length times width, 4 times t, and then times h bar, which is 7.5. Ilan po yung eccentricity natin. Okay, it's 0.1. So we can now use these values to determine the depth of the center of pressure. So we have 7.5 meters plus 0.1 meter. This is equal to what? 7.6. Okay, 7.6 below the surface. That's the location of F sub H. So somewhere around here at this point. Dito nag-a-act si F sub H. Okay. So what about the location of F sub B? Location at F sub B, we can look at the free body diagram and determine the location relative to point A. This is point A. This is F sub B. Okay, this is F sub B coinciding with F sub 1 and W. So we need to determine this. Now, the F sub B, or the weight, acts on the centroid of a quarter circle. But nasan po ba yung centroid ng quarter circle? Well, we can look at the table. Let's look for quarter circle. Yan. And then, this is your formula. So we have 4r over 3 pi. Okay. So again, that centroid is the point na magpapass to yung weight nung tubig at the same time yung F sub B. So yan yung distance na hinahanap natin. It can be solved by 4r over 3 pi. So we'll substitute the value of the radius, which is 3 meters. Okay. So the location of F sub B relative to A is 1.27 meter. Any questions? Any questions po? So before we proceed to module 4, which is analysis of dams, let us take a quick break for 6 minutes. Let us resume po at exactly 11:40 a.m. Okay, so you can grab a lunch. Okay, you can grab a lunch because we'll be extending our class time, no? So probably until 12 p.m. So matapos po tayo 12 p.m. But feel free to eat while you are listening to our discussion. So yeah, let's resume at 11:40. Okay, so let us resume. If you are still with me, please type yes in the chat. Thank you. Let us now discuss analysis of dams. So we'll just discuss the basics. So analysis of dams or dams, just to give you a background, they are built for the purpose of impounding water. So we have different types of dams. The most common type of dam is the gravity dam. Okay? So the dam is basically hold by its own weight for it not to topple. Because the water or the dam is holding a reservoir, right? Basically. So, for example, Angat Dam, you can see that it's a concrete dam, it's a gravity dam that's holding this reservoir, this water that is used to supply water in Metro Manila. So that's the purpose of a dam is for generation of electricity, used for as water supply, it's used for impounding water for agricultural purposes, irrigation purposes, or maybe it's just a retainer. So when we say retainer, when in the event of a typhoon, we hold the water temporarily in that dam, in that reservoir. Then after the typhoon pass, after the typhoon end, so we open the gates for the dam for the water to flow. Okay, that prevents flooding in low-lying areas. So these are some of the many um, many purposes or uses or benefits of dams. Okay, there are a lot of reasons why we build one, but these are the main reasons. So electricity production, air supply, impounding of water in the event of bad weather. So what we're gonna uh, study today is the analysis of forces. Okay, analysis of forces that's caused by the fluid or the water to the dam. Okay, so it's important in designing because we want to know first what's the forces that will be acting on the dam so that we can select or we can design it appropriately. So that class is the essence of engineering mechanics in civil engineering. So in statics, if you can recall, we determine the forces internally and externally for, let's say, example, a class. And the reason for that is we design, we can design the appropriate sizing of the um, members given that it will have this magnitude of force. So we anticipate. That's the purpose. That's the goal of designing. That is to simulate the reaction of a structure on paper, so that in the event that it is built, it will not. It will be safe. Um, it will not. What's the word? It will not give in into these forces. It will not fail. Yun. Okay. So let us now go to the PowerPoint. So let me share my screen. Again, dams are built for the purpose of impounding water. And we have here an example of a dam. So this is the cross-sectional look of a dam. Okay. So this is the side view. No? This is the dam. This is a gravity dam. Gravity dam made out of concrete. Okay? So, buhos po ito. Pure concreto na merong bakal sa loob. So, reinforced concrete yan. And this dam is used to impound this water. Okay? So, we have a reservoir. Sorry. We have a reservoir on this side. Now, in some cases, we have water on the other side. Okay? But in other dams, this side, no, is not filled with water. Okay? But in the event of having one, so we consider um, um, this side to have water or reserve water. Okay, so these are the important parts of a dam. We have the heel and then the toe. And then this is the first force that we can see that acts on the concrete dam. So we have its self weight. Okay. Applying the summation of force equal to 0, vertical. We have W of dam minus weight of dam. So, transposing this on the other side, we have this. Okay. Gamma of concrete times the volume of the dam equals the weight of the dam. Okay, so we just have to get the dimensions of this dam and divide it by the unit weight of concrete. Okay, so another force that's acting on this dam is F sub U. So that's the hydrostatic force on the upstream side. Okay, so we have two sides again. This is the upstream in which the heel is present, and then on the other side we have the downstream. So when the water is released, it goes from here to here. Okay, that's why this is the up and then this is the downstream. On the downstream, the toe is located. Okay. Now, since we have water here, we will have another hydrostatic force. Okay, so we have this F sub dH. That's the horizontal hydrostatic force on the downstream side. Okay, so far we have three forces that are acting in the dam. We have the self weight of the dam, the hydrostatic force on the upstream side, and the hydrostatic force on the downstream side. Now, on the downstream side, we notice that it's triangular in shape. So, not only that it has horizontal hydrostatic force, it also has vertical. Okay? So, on this side, we do not have because there is no concrete that's acted upon by the water vertically. Whereas on this side, we have one. So, this is F sub dV, vertical hydrostatic force on the downstream side. Now, to solve this hydrostatic force pala, so we use these equations. Okay? So, for F sub U, so it's gamma times H bar times A. Same as the formula that we use on F sub H. And then for the horizontal hydrostatic force on the downstream side, we have gamma H bar times A. And then for the vertical hydrostatic force on the downstream side, we have the weight, okay, computed by multiplying the unit weight and the volume. Okay. So another force that will act or that acts on a dam, the horizontal reaction of the supporting soil, and vertical reaction of the supporting soil. So basically, this water will push the dam, and this dam is rested on this soil, so this soil will resist. So it will have a counteracting force going to the left, going against the direction of the upstream. And then we have the vertical reaction of the supporting soil. This soil will resist the weight of the dam. We will have R sub D, the vertical reaction. X bar is the location of vertical reaction relative to tau. And then we have this uplift pressure. Okay. Now, what is uplift pressure? Uplift pressure is the pressure that is exerted by the water that seeps through the voids of the soil. So this water, okay, some of this water may seep to this soil. Okay. And ang nangyayari is there will be that water will have the tendency to go here on the top side, on the downstream side. Okay, so it will go up. It will have a pushing effect on this dam. So there will be an uplift pressure due to this seepage of water. Okay. So we also consider that in our calculation because some of the dams in the past failed because of this uplift pressure. They did not consider it in their calculation. So what happened was the dam overturned. So it failed due to this pressure, and there's been of course, but when this big of a structure fails, there will be casualties. So we should consider this uplift force or uplift pressure for us to make sure that the dam that we're designing is safe. Okay? So we have this U sub U and U sub D. So what are those? U sub U is the hydrostatic uplift pressure on the uplift or upstream side. Okay? It can be computed by multiplying the unit weight by the height. So in this case, it's unit weight of water. And then we have U sub D. So U sub D is the hydrostatic uplift pressure on the downstream side. So it can be computed by multiplying the unit weight of this liquid times the height. Okay? So the height or A sub U is the height from the surface up to the heel or down to the heel. Okay, that's A sub U, and then A sub D is the height from the surface to the toe. Okay? So how many forces are there in so far? So 1, 2, 3, 4, 5, 6. Okay. So we have this factor of safety that is equal generally to resistance over resistance. For us to make sure that the dam is safe or the structure is safe, the factor of safety should always be above 0. Okay? At least 2 above. Okay? So if our factor of safety is 2, if the resistance is twice the resistance, then we can make sure that the dam is safe in this category. Okay, but because if we are about to build a dam, there are a lot of considerations, of course. Yung dinidiscuss lang natin dito on the forces, pero wala pa dyan yung geotechnical, yung structural, yung soil. Okay? It should be strong enough to withstand the loads that will be applied by the water and the dam. So there are a lot of considerations. And in the planning stages pa lang, ng pagtatayo ng ganito kalaking structure, it takes years. Okay? Years of planning, years of designing prior to the construction. Okay? Imagine that. And today we're just discussing the forces. So this is just a small piece of a big picture, kumbaga, of the design and planning of dams. Okay, so yeah, just to give you an idea, perspective. So that's factor of safety. Now we have two types of factor of safety. We have factor of safety that's factor of safety in terms of overturning. So righting moment should be uh, more than overturning moment. Okay? So meaning the forces that will be exerted by the water should not be more than the forces that will be exerted by the weight of the dam. Because again, gravity dam, they rest on the weight of the concrete. So that's the righting moment. And the overturning moment is the moment that will cause the dam to overturn. So ito yung hydrostatic force, ito yung uplift pressure na magkukos sa dam na mag-fail. Okay? So kumbaga kung ito mas malakas kaysa dun sa moment na kinakos ni weight, edi mag-overturn si dam. Okay? So righting moment should always be more than overturning moment. And this is how we solve the factor of safety. We divide the two. And then we have another consideration. So hindi lang overturning, we also have sliding. Okay, so we do not want our dam to move, okay, due to the horizontal force of this reservoir. So we consider the R sub B, or the vertical reaction of the supporting soil, and we multiply it by the coefficient of friction of the soil. Then we divide it by R sub H. So this one should be more than R sub H, or horizontal reaction of the supporting soil, for it to not slide. Okay? So That's the brief explanation of dams, analysis of dams. Let us now go to the problem. Okay, so we only have one problem here. Actually, this is the last problem for today, in fluids. So let us read and answer this sample problem. We have to determine the critical height of the water level before the concrete gravity dam starts to tip over due to the water pressure acting on its base. Assume water also seeps under the base of the dam. Specific weight of concrete is 150 pounds per cubic foot, and assume uniform seepage pressure at the base. So, meron tayo ditong rectangular na seepage pressure. Okay, we have a hint. Work the problem using a 1 foot width of the dam. Okay, so let's answer this one. Ay, sorry. Shopee ba? Shopee pa rin ba hanggang ngayon? Kanina. Pero ngayon. Hindi na. Sige, sige, sige. Pasensya na. Hindi ko kita eh. Pasensya na kayo. Okay. Let's answer this. So, una po muna natin gawin is i-drawing yung figure. So, meron tayong concrete dam. Ito. Hill. Then we have water on the upstream side. On the downstream side, we do not have water. Okay. So, we want to get H. The height of the dam is 12 feet. Then the base of the width is 4. On the top, it's 2. Okay. So we want to get the height of the water level before the concrete gravity dam starts to tip over due to the water pressure acting on its base. So we will use summation of moment here. Okay, but let's draw the uniform seepage pressure muna. Okay, so meron tayo ditong uniform seepage pressure. So i-assume natin na may nag-seep na tubig dito. And then uniform, so yung drawing natin is rectangular. Okay? So ito U. No? So, ano po yung gagawin natin? Well, again, we will use summation of moment. Okay? We will take the summation of moment at point A, considering all of the process involved in this dam. Now, ano-ano po ba yung forces involved? Well, unang-una, yan, dinawin na natin, meron tayong uniform seepage pressure. That's number 1. Okay? Number two, since meron tayo dito ng tubig on the upstream side, it will have a hydrostatic force. Okay, so let's write F sub H here. That's the magnitude of the hydrostatic force. We can draw the pressure diagram. Okay, it looks like this. So this is the second force that's involved in this dam, no? That's acting on this dam rather. Horizontal force, uniform seepage pressure, and then we have the weight. Now this dam, we can divide this into two common shapes. So you can see here, we can divide it in a rectangle and a triangle. So this dam has self-weight. So that's the third force involved. Okay. So we divide it into, we have weight of concrete for this rectangular figure, and then we have weight of concrete for this triangular figure. But if we add these two, we add this weight, then we will get the total for the dam. Okay, so now let us solve for the magnitude of each of these forces. Okay? Each of these forces. So we have F sub H. To solve for F sub H, this is equal to gamma H bar times A. So unit weight of water is 9.81. Then we have H bar. So H bar is half of this H. So therefore we have H over 2. And then we have the area. So the height is H. So that's the unknown. And then we multiply it by what? We multiply it by 1. Okay? We assume 1 foot width. So we have this equation. We can simplify this. So 4.905. H squared. Okay, so that's F sub H. Now we can go to the other forces. Let's go to the weights. So let's solve for the weights, no? W C sub R and W C sub T. To solve for the weight, we multiply the unit weight by the volume. So what's the unit weight of concrete? It's given here. It's equal to 150 pound per feet cube. Okay, it's not shown dito sa canvas or sa BBB. But ito yung unit weight natin. So, okay. We multiply this by the volume. Let's look at the figure. We have 2 times 12 and then times 1. 2 and 12 are the dimensions of this rectangular figure, and 1 is the weight. So what is the weight of that rectangular concrete? Okay, thank you. 3,600. Okay. What about the weight of the triangle? So unit weight 150. And then we multiply the volume. This is a triangle. So we have 1/2 base times height. So the base is equal to 2. 2 feet. The height is 12. And then the width is 1. So ano po yung weight ng triangle? Okay, 1,800 pounds. Okay, so we already have the values for F sub H, W sub R, W sub C sub T. We only have to solve for the U to complete the forces. So how do we solve for U? We look at this slide. So it's gamma H. Gamma H. Okay. So okay, we are in the English system pala. So we do not use 9.81. Sorry, I have a mistake dito. So this should be 62.4 pound per feet cube. Okay, so this should be 31.2. So going back to you, 62.4 pound per feet cube times height. So that's the equation for U. So this shows the unknown, and we have to take summation of moment about A, because these forces F and H, FH and U rather, should be resisted by the weight. And dinidetermine natin yung H, yung amount ng H, before the gravity dam starts to tip over due to this water pressure. Okay? So, moment tayo sa A. Okay? Summation of moment at point A equals 0. Clockwise positive. So, we have to determine the moment arms for these forces. So, let's start with W sub CP. The weight acts on the centroid of the triangle. So this is the centroid of the triangle. It is 2/3 of the base from point A. Okay, that's the moment arm of this W sub CP. So putting it in the equation, summation of moment times the moment arm 2 over t times the base, which is 2. So this will become 4 over t. Okay? It's positive because it will rotate clockwise. Next, we have W sub CR. So we need to get the moment arm. So this is 2 plus half ng 2 feet. 2 plus 2 over 2. Therefore, this is times 3. Okay? We have 2 plus 1 equals 3. Then we have f sub h. Okay? Positive sa W sub r na pala because at about A, at about point A, this force will produce a clockwise motion. Okay? So, for the next force, f sub h, we need to get the moment arm, and it's 1/3 of the height. Okay? Because this is a triangle, and this f sub h acts at the center of that triangle. So, what's the value of f sub h? It's 31.2 squared. Multiply this by the moment arm, 1/3 times height. And then the last force, u. So we have minus again because this will produce a counterclockwise rotation about point A. Or same with f sub h. So this is 62.4 times h. Okay, this 62.4 in unit, this is pound per feet cube. Okay, so we need to cancel that feet cube. So now this is feet squared. We have to multiply 4 feet and 1 foot. Okay, we multiply its length and then the width of the dam. So we have 4 feet times 1 foot, and then this is equal to 0. Okay. So this is our equation. Let us simplify. What is 1,800 times 4? 4, and then 36 times 2. I think this is 10,000 something, 10,800. And then minus 31.2 divided by 2. 10.4. And take a look. H, this is h squared multiplied by h. So this will become h cubed. And then we have this minus 62.4 times 4. And then okay, we do not have the moment arm pala. No. So moment arm nito is half of this rectangle, which is 4 over 2. Okay, so we have 62.4 times 4 times 2. This is 499.2. Then we have H equals 0. So we have a cubic equation. Okay. Now let us rearrange this. It will become okay. One equation, one unknown. What is the answer? What is H? You can use shift solve to answer. Ano po yung H? It's 9.36 feet or 9.35 ganti. We have this answer. Any questions? Sorry. Okay. So let me repeat what I said. The analysis of dams PowerPoint is already published. The assignment and quiz will be published later. Now, we shall expect na yung deadline po nito is until next week pa. So, iseset po natin siya until Friday next week. Okay? And ito lang po yung asynchronous activities natin for this week. Okay? Itong assignment na to, tsaka yung quiz na to. So, due date niya until next week. Friday, April 22. Set po natin dyan para hindi maapektuhan yung long vacation natin, long weekend, April 14 up to 17. Okay, so I don't want to interfere with your vacation. So if yeah, you can do the assignments by next week pa. Okay? So yan yung asynchronous class na asynchronous activities natin. And then wala po tayong pasok, of course, sa Thursday saka Saturday. So yung susunod po nating meeting is on Tuesday next week. Okay, probably yun na po yung last meeting natin. Okay, so medyo mabilis lang yung pacing talaga. I-discuss po natin at that day yung buoyancy. Yun po yung susunod na topic. Okay? So, yun. Any questions po? Yung bibigay naman natin na assignment and quiz. I'll see nila to what we answered dito sa klase. Okay? And para doon sa quiz na pala, Um, hindi siya yung type na mayroong time limit. Okay. So, para siyang assignment na problem set. And then you can see it, you can access it anytime, basta pwede nyo siyang sagutan hanggat hindi pa siya deadline. So, yeah, that's the uh, quiz, no, for module 4. So, any more questions po? Any more concern? Let me just check our attendance and then we'll end the conference. It's okay na I mark you as present naman. Okay, so yeah, thank you for attending our class today. I hope you learned something. Let's see each other again on Tuesday next week. Have a peaceful Holy Week, everyone, and stay safe.